Now in this video, we are going to learn how to find the successor of a node through these Visualgo animations. So let us start with the node 41 uh, in here. So I have typed 41 and now I want to find get successor. So here what it will do is, as I have told earlier, all the processes are just opposite to predecessor finding. So for example, in case of predecessor, it was checking whether the left child or the left hand side of the node is null or not, but instead here it is checking whether the right hand side is empty or null. And if so, instead of finding max on this dot left, we are doing here finding min on this dot right. So exactly opposite. So let's see what happens through an animation quickly, and I believe everything will be clear very soon. So we starting from 41. So in the first line, it is checking whether the right is null or not. Well, of course, it is not null because there are lots of things in the right hand side. And after coming to this right hand side or the right child, then it will start finding mean. Means it will come all the way down to the left as far as it can go. So here it is finding the mean, and this is how. So it came to 50, then after 50 it came to 46 until it found null in here, that is empty left. So 46 is a leaf node, so the process ends, and it is now output that the successor of 41 is 46. So this is one case, but just like predecessor, there is another case also. If the right hand subtree or the right child or the right part of the node that you want to search, if that is null, for example, the node like 32, what will happen in that case? So let's just try to understand that also. So here I'm putting 32 and let's put get successor. So what will happen now is, as you can understand, first it will come inside this else part because the right side of 32 is totally empty. So it is null. So it did not go inside the if part and it directly hit the came inside the else part. Now here again, it just like the predecessor, it uh, initialized two different variables. The first one is a temporary variable to hold the parent, and then the second t variable, a temporary variable to hold the current node, like this node. And then again, the similar way the predecessor has done it, also this algorithm also has a while loop where everything is same as predecessor, that is the parent node is not equals null, and until this part it is same. However, the only difference is, instead of finding p equals p dot left, this time it is checking p dot right, and everything else is just same as predecessor. So by changing this one from left to right, what it is doing is basically in doing it is what it is doing is, it is basically going in the upward left direction as much as possible, and once it cannot go anywhere in the left direction upward, it will just make a one move to the right direction upward, and that is it. what it is doing. So let's see the animation and it will clarify everything. So 32, so move one step up. So I'm sorry, so I just hit the end button by mistake. So we were here. So inside this else, what will happen is, so first it will go all the way up until up in the left direction. So it is moving to 29, then again moving to 20, and that is it. It cannot go any further in the left direction, in the upward direction. So it is the time to make the final right move in the upward direction. So it just make the move, and now as you can see, right after this move, it is the successor. It found the successor as 41, and here the process ends.